Hi guys, in this video we're going to have a look at how we solve quadratic inequalities. So this is very similar to factorising quadratics or solving quadratics by factorising, so check out that video because that's definitely going to help you. And of course, if you're unsure what inequalities are, make sure you watch the inequalities video before this one because we are going to rely on previous knowledge. So let's get started. You'll notice that x squared minus 2x minus 3, x squared minus 2 minus 3, so they are exactly the same quadratic. The only difference is the inequality is the other way around. So this one's saying this is less than 0. Remember, we always point towards the smaller amount. So this is less than 0. And this one here, because it's pointing the other way, we're saying this is bigger than 0 or greater than 0. Okay? So I'm going to show you what happens in both situations. First step is exactly the same thing as we would do if we were solving a quadratic. We need to factorise it. So I'm going to draw my grid, and again, if you can't remember how to factorise quadratics, check out that video as well. So x squared goes there, and I have my minus 3, and of course x times x gets me my x squared. What numbers multiply to get 3? I've only got one option there, 1 and 3. So I can put those in there, which will give me 3x and 1x, or just x. But how do I use them to get minus 2x? Well, in that case, it's going to have to be minus 3x plus 1 to get minus 2. And if I change that to a minus 3, I must remember to go back in there and change that to a minus 3 as well. So all I've done there is factorised it. So I'm going to have one solution of x plus 1. And I'm going to have x minus 3. And of course, I've got my inequality symbol there. We're saying it's less than 0. And I can come over here, I suppose, as well, because it's going to factorise exactly the same, because it's exactly the same quadratic. But that's saying it's greater than 0, like so. Once you've done that, just like we did if we were solving quadratics, we would then work out what x needs to be to make this bracket 0, and what x needs to be to make this bracket 0. So set it equal to 0, and then just solve it by minusing 1 to both sides. So x is minus 1, and this one here, set that equal to 0 plus 3 to both sides. So I have x equals 3 as well. Same thing over here. So x would be minus 1 and x would be 3. Excellent. Now, this is where it's slightly different because it's after inequalities, and you have to be very careful about how you actually write your final answer. And the best way I've always found to do this is to draw a very quick sketch of what it will look like. So I'm going to draw my x and y axis like so. Just a very rough sketch, doesn't have to be anything posh. And you might remember, if you have seen my solving quadratic equations via factorising, I had a little sketch. I showed you the actual graph, and it means that it will cross, when you sketch this, the x-axis at minus 1 there, and at 3 is 1, 2, 3. I use my squares. Okay, so I've got minus 1 there, and I have 3 there. And a quadratic curve is always like this. Okay, so a quick little sketch with my solution. So that's minus 1. And that's 3. Once you've done your little sketch, you can then use that to help you to finalise how you write your final inequality. So when we look at this one, this quadratic is saying it's less than 0. So when is this less than 0? So here's my y-axis, and we have a look at our curve. When is it less than 0? Well, 0 is there, so when is it less? It's when it's between minus 1 and 3. This is when the curve is less than 0. Okay, so that's how you then need to write your inequality. So if I have minus 1, x needs to be greater than minus 1 because it needs to be bigger than minus 1. However, it needs to be less than 3. Okay, so we're saying that any value, x, any value between minus 1 and 3 will satisfy when the quadratic is less than 0. And the other thing you could be doing, if the inequality was the other way around, we're saying, okay, well, when is it greater than 0? Well, we've got two options. When the curve is greater than 0, we're looking at this part here. Okay, when we're saying x is less than minus 1, any numbers going down here are less than minus 1. So we're saying x will be less than minus 1. So in other words, minus 1 is bigger. It's pointing at the smaller number. So x is less than minus 1. And we also have this part here, which is greater than 0. Okay, this area here where we're saying that x is greater than 3. So when x is bigger than 3, it's above 0. And when x is less than minus 1, it's also greater than 0. So that's how you can solve your inequalities. We factorise, draw a little sketch with your solutions from factorising, and then just see which parts are greater and which parts are less than 0. Okay, so I'll do another one as well, so you can see it in action again. Let's change my sheets over. There we go. So exactly the same thing. I've got a quadratic here, which is less than, and remember that means equal, so less than or equal to 0. Exactly the same quadratic, but this time greater or equal to 0. So the process is still the same. We still factorise. So my x squared goes in here, and I have my minus 12. X times x gets me x squared. And let's find some numbers that multiply to get 12. 1 and 12, 2 and 6, 3 and 4. So which one of those am I going to use to get minus x, or just 1, however you want to think about it? It's definitely going to be the 3 and the 4. The difference there is 1. So put 4 there and a 3 there. 3x and a 4x, but I need to be minus x. At the minute it's 7x. So to get minus 1, if you like, or minus x, if I take away 4 and then add 3, that's going to get me my minus x. And if I do that, I must remember to go back up there and add my minus up there as well. So that's x minus 4. Writing it out, I have my x plus 3 in one bracket, x minus 4 in the other bracket, and of course then it's still less than or equal to 0. When I solve it, I set here x plus 3 equal to 0, so minus 3 to both sides. So x equals minus 3, same thing over here. X minus 4 equals 0, plus 4 to both sides. So x equals 4. So there's my two solutions. Obviously it's the same for both. And I'm going to draw my little sketch here again. So just a very quick sketch. It doesn't have to be perfect, just to give you the idea of when it's above and below 0. So I've got x is minus 3. So there's my minus 3. And it crosses the x-axis at 4. So there's 4. And again, just do a very quick sketch of what it looks like. It doesn't have to be perfect, it's just to give you the idea. So again, when is this quadratic less than 0? Well, again, there's the 0 on the y-axis, so it's this part here that is less than 0. So it's when a number, or x, is between minus 3 and 4. So exactly the same thing here, it's minus 3. This time though, because it's a less than or equal to, you must do the same thing there. It can also be equal to. So when x is greater or equal to minus 3, because it's greater than minus 3, but it's less than or equal to 4. Okay, so that's the answer to that one. What if the inequality was the other way around, and this was actually asking you for what was when it was greater or equal than 0? So again, when is it greater? We're looking at this part here, when x is actually less than or equal to minus 3. So x is less than or equal to minus 3. Remember, it always point towards a smaller number, so x needs to be really, really, really small. And likewise, this part here is above 0, so when x is really, really, really big, in other words, x is greater or equal to 4. So there's your solutions for those ones there. Okay, let's have a look at what happens in some special cases. So just bear with me a second. So, two examples here. We've got this one here. Well, this one isn't equal to 0. So just like if you were solving a quadratic, you need to make it equal to 0. So before we crack on with this, we just need to do a little bit of rearranging and make it equal to 0 so we can actually factorise it and find our solutions. Oops, I've missed off the minus 8. There we go. Okay, so now we can crack on just like we were doing before. So we factorise x squared, and of course the minus 8. X times x is x squared, sorry. And then I need to find some numbers that multiply to get to 8. So 1 and 8, 2 and 4. Which one am I going to use to get me a 2? Definitely the 4 and the 2. So 4 and 2, which gives me 4x and 2x. At the minute, if I simplify them, I have 6x. I need minus 2x. So I'm going to do minus 4x plus 2x to get the minus 2x. And again, I need to add it back up there as well. So I have my x plus 2, x minus 4 is greater than 0. And I'm going to find my solutions by setting these equal to 0, minus 2 both sides. And my solutions here add 4 both sides, like so. Excellent. Now comes my little sketch. And I have minus 2 there, and I have 4 there. And a little sketch here. And I'm after, when is it greater than 0? So it's these parts here that are greater than 0. So it's going to be when x is really, really small. So x will be less than, not equals this time, just a less than minus 2. And when x is really, really big, when it's greater, when x is greater than 4. Okay, again, always pointing towards the smaller one. So if you get something like that, don't be put off, just rearrange it, make it equal to 0, and then it's exactly the same as we've seen. This one here is a little bit different. There's different ways you can do it. It's entirely up to you, but I think this is the easiest way of doing it. You don't want to have a minus x squared. If you have a minus x squared, it flips the curve over and it just makes things a little bit different. So we want to have a positive x squared. So all you're going to do is just rearrange it and take it all over to this side. So to do that, I'm going to add x squared to both sides, which leaves me with 5x plus 6 less than or equal to x squared. Then I'm going to minus 5x to both sides, so I'll have 6 is less than or equal to x squared minus 5x. And then finally I'm going to minus the 6 to both sides. Oops, getting keen. So I'll have 0 is less than or equal to x squared minus 5x minus 6. Now it's positive, just makes it that slightly bit easier to work with. So there are other ways to do it, but I quite like this way, just because then it keeps it all the same. Exactly the same process. We now need to factorise it. So I'm going to have x squared and minus 6, so x and x. And numbers that multiply to get 6, well I've got 1 and 6, and 2 and 3. Which one do I use to get 5? It's one of those ones where you could use either one. So a little bit of trial and error here, so we need to check it. I'm deliberately going to get it wrong the first time and pick 2 and 3. So if I pick 2 and 3, that gives me 2x and 3x. That gives me plus 5x, i.e. minus 5x. So they would both be minus 2x and minus 3x, which gives me a minus 2 and a minus 3. So it looks okay as far as this minus 5 goes. However, when you check the numbers, minus 3 times minus 2, minus times a minus is a positive, not a negative. So that one doesn't work. We need to use that one. So I'll very quickly just do that. So 6 and 1, which gives me 6x and just an x or just 1x. Need minus 5. So minus 6 plus 1x gives me a minus 5x. Means that needs to be minus 6 there. And then 1 times minus 6 is minus 6. So that's the one that works. So always check that those numbers multiply to get that one as well, because you do get cases like that. So now I factorise it. I now have... nope, it's that way, isn't it? Yeah, there we go, because 0 is on there now, so this 0 is less than all of this. Okay, and then I get my solutions. So x minus 6 equals to 0, so plus 6 to both sides. x equals 6, x plus 1 equals 0, minus 1 to both sides. So x is minus 1. Little sketch, very little sketch, I've run out of space. So we have minus 1, 1, 2, 3, 4, 5, 6 there. So there's my minus 1, there's my minus 6, and my curve. And we're saying, okay, well, when this is greater or equal to 0, remember, we're always pointing at smaller. So 0 is smaller, which means this must be bigger. So when are we bigger? Well, when x is really, really small. So x is less than or equal to, again in this case, minus 1. And when x is really, really, really big, so when x is greater or equal to 6. I don't know why I put minus 6 there. That should be a positive 6. Okay, so hopefully you've seen a couple of different things there to watch out for, and the process to actually solve quadratic inequalities. Hopefully that helps, guys. Thanks for watching.